right? Based on all the sessions that you guys have given. So the one part is, choosing the right algorithm and cleaning up the data and training the algorithm to really, whatever the algorithm that you choose for the use case, training them to kind of make sure that it is well prepared. So any new thing comes, it's able to, give us the solution right away at a very high level, okay, without getting into the
Yeah.
details. So this is the whole part of a data science task, right? Data scientist task, right?
Yes. Yeah.
And when it comes to the software developer, there's two aspects to it. One is obviously understanding all these different models built by different people that are out there to build some software products around that could fulfill their use cases, right? That's one way of just being an application developer, right? Not really anything on top of that, right? That's one way of doing it. And then the other way of doing it is coming up and creating new models. So when it comes to new models, you mean the software developer's role won't be there at all, or how? I'm just trying to connect the dots.
No. So if you go back, let's say 4 or 5 years, right?
Mm-hmm.
There were a lot of models that went out there. So if you want, you would have to do the data science part a lot more and the data engineering part a lot less. So what that means is that I would need to get my own data, label it, choose a algorithm, and then apply it to some real world use case, right? That's
Mm-hmm.
what I would do as a data scientist. Now it's more about knowing which models to use, right? Because the models are already pre-built. You won't make them from scratch again.
Mm-hmm.
Where the data science part comes in is more about knowing how this model that you're picking up from a shelf will be able to solve your unique use case. Um, Maybe in data engineering, so you're making sure that you have a pipeline that allows these data science solutions to be applied in a meaningful way and with a lot of automation. So that's where more work is focused now, as opposed to before when you were working on making the models from scratch.
Understood. And the data engineering, you mean the software developers?
No, so data engineering is, for example, there's a whole field of supporting data scientists with data engineering. So you would have data pipelines where data comes in, let's say from a user, it's labeled in that pipeline, and then it's used to maybe go into a model that then improves its accuracy using the new data. So
Mm-hmm.
building that whole pipeline is also part of data engineering.
Okay.
Uh, so, people who are data engineers are people who are very good with Hadoop. Obviously, they know their SQL, stuff like that.
Mm.
Um, so that's also very important.
And the data, okay. So I was kind of always overlapped. Sorry to hijack, Harsha. I was kind of a little bit. Maybe it's useful for others too, or should I stop here? Just to get a clarification of the difference between the data scientist job, data engineering job, and actually the software developers and testers and operations experts. How do you actually categorize them of testoper personas into these different categories? Could be good to understand.
You can continue, Kadir. It's okay. We can. Anyways, we'll have a little bit of pandas left for next week, so I can add more sections. That's not a problem.
Sure. So let's take 3 minutes to get this
Yeah.
clarified, Shad, right? So Shad, it's, go through a flow. Like, we are testoper community. We focus on software developers, testers, and operations experts, right? How do we actually fit into data scientists, data engineering, and software development, where the actual innovation in this whole pipeline comes into the picture? If you could give some clarity at a very high level, would be very appreciated.
Yeah, sure. So let me um, let me give an example. So let's say you're a bank and you want to make a ID validation tool, right? So what you want to happen is, to the end user, you're going to provide basically the ability that they can scan their ID and the ID is automatically validated, right?
Okay.
It's a simple topic. So from the data science point of view, what the data science scientists will focus on in this use case will be OCR, which is optical character recognition, and object detection, right? So he's going to take these two models and he's going to try to figure out if using these two models you can detect with confidence whether this ID card is valid or not. So
Okay.
that is the domain of the data scientist. Now within this, the data scientist can't do anything unless he has training data, right?
Mhm.
This training data will allow him to train the object detection model and pick out inaccuracies in the OCR. So then how does the data get from the users to the data scientist, right? And again, this assume that there's an application that's already been developed and now you want to build this model. So now the data engineer comes in and he's going to set up the infrastructure which will allow training data to come into the data scientist. And this could come from anywhere, right? You might go to an outside source to get training data. It doesn't matter. But having a pipeline where data is coming in, it is getting labeled. So labeling is basically knowing that, okay, this is an ID card, this is not an ID card. So creating that pipeline is the work of the data engineer here. So from that pipeline, the data will come to these models. The data scientists will check the accuracy of these models. They'll find ways to improve the accuracy. And then the output of this would be some kind of API, right? Now the API is something that would be developed maybe by the software developer here. And what that API is going to do is it's going to take in a picture, it's going to use the model, and it's going to be able to say yes or no, this is a valid ID card.
Mhm.
And now applying this model and making it available in the end user application is the job of the software developer.
Okay.
So, and then again, this is like a whole cycle, right? So as new data is collected, as more people scan their ID cards, you might have that data coming back through the data engineer's pipeline to the data scientist, and then they'll use that input to further improve their model.
Yeah.
So that's how these are structured.
And the people, the software developers can obviously build an API and they can provide that API as a service, right? For someone else
Yeah.
to use that API and build their own application, and that guys could be another software development team.
Yeah.
Maybe they're building bigger application. In that one application, one small thing is just ID stuff. Okay, got it. Got it.
So all the three roles are very important. And obviously, after software engineers, you have software developers, you have the QA people as well, who make sure that, for example, it's not taking too long to do an ID scan, stuff like that. Just all of that stuff.
Pretty clear, pretty clear. I hope at least it helped me to really classify, and I'm sure that the QA, data scientists, whenever they are choosing the model and doing stuff indirectly, they are doing in that part also some QAs, right? Because they're testing it and stuff like that, no?
Yeah.
And
But that kind of QA is more focused on the data science part, right? It's not focused on the end application.
Got it.
Yeah.
Got it. And then you have engineering, and then you have software developers. And now the business case could be a company who builds all these different models and provides an API for anyone to come and build the applications using their, models. That's what you're mentioning, right? So that could be one business model for a company who is platform experts like Microsoft or any other small companies. And then the second option could be that a company which builds an end-to-end application and they also do everything what you explained and give that whole thing as a the first one is a platform as a service, next one is a software as a service, right? The whole thing as a software service to someone else. Okay, so all those things fall under the traditional business models of PaaS, SaaS, and all. Okay, got it. Pretty clear. I hope it also helped some of you to answer some of your questions. But if you have any questions, please ask. Yeah.
Yeah, this is Partha. The one of the main businesses today is to provide training data for different domains. And yeah, if you look for people who are providing training data, that's really big business. It's still in the not gone into the mainstream, but there are many small and medium businesses which are doing this. So if you want to really build something end to end, I believe a company today who wants to do something like that, they actually go out and get the different pieces together, and you're more interested in putting the pieces together and then getting your business logic done and get your actual application working. I just wanted to say that providing training data is big business.
Yeah, yeah. And in telecom field, it's also important that I learned something I want to share. So in the telecom field, what happens is there's a lot of data that gets streamed in real time, right? To understand, let's say I'm talking to Partha, what is the voice quality of that call? And like there's a lot of data that gets generated in the network, big network that Rogers Tellers has. And all these data get streamed into a big data lake sometimes, and they don't use big data lake. Sometimes they use Spark and things like that for real-time streaming, and they real-time stream. And what they do is they find a pattern, right? Like Harsha was explaining, they find a pattern which they consider it as a baseline. It's not a training data, right? The data is coming in real time, and they create a baseline, and then they detect anomaly, right? So okay, this is my baseline, this is the quality. Let's say you and Partha and me are talking just for the arbitrary sake of discussion. It's 1 to 10 scale, right? So the all the data that is being received in real time, everything is showing somewhere around 9.5. So they consider that as a baseline. And something, if it goes down to, let's say 8.5, they are detecting that as an anomaly. And then when that happens, then they are actually going and looking into the detail, which requires telecom expertise to look at all those data that they are getting to really find out why the deviation is and which customers got impacted and so on. So this is more from the point of view of identifying which customer is impacted because of the bad quality. But what they are also trying to do is predicting it, the future. So they have been doing this data throughout, and it's happening in real time. And over the period of time, based on the past anomalies, they are able to predict in future, this is going to happen, that is going to happen, and make sure that you go and see this problem doesn't happen in this area, which was the trigger in the past problem. I mean, from the story point of view, it looks very catchy and attractive. Now the question, this is more for Shad and Harsha. How do you map what this is happening to what all we are learning today? And this is what they are doing it in the
Yeah. So in your example, you mentioned detection of anomalies, right?
Yeah.
So what we're doing today is most related to recognizing those patterns in data.
Okay.
Applying that or making a business solution out of it is something that is not being covered here. We're more focusing on the work that the data scientist in that situation would do, which would be looking at the data and figuring out what the pattern is, right? And defining what an anomaly is. Now, taking those rules and applying it to the data, that would be something that maybe a data engineer would do, right? Or the data engineer would create a system where those rules or models defined by the data scientist would be applied.
Got it.
So,
But you understand what I mean? It actually, all these data comes online, right? It's real time, and the pattern is detected in real time and without any configuration. So in the past, we used to configure, okay, if the quality is above 9, it is good. If it goes below 9, it is bad, whatever. But nowadays, they don't even do that configuration. They are skipping that configuration. They're saying through the AI, they are detecting the pattern, and they are automatically detecting the anomaly, and then finding a lot of things with the data.
yeah, but the AI model needs to be developed, right? So that development phase of the AI model is what we're covering here.
Understood. Okay.
Just wanted to add something to that. You see, if you look at any one of the Zoom calls or something, or a WhatsApp call, at the end of the call, it says, "What is the call quality?" You're asked a question and you rate it, right? So this is part of the training data. If somebody wants to provide training data for this type of thing, so there would be a set of people sitting there and introducing noise into a signal and actually mapping that, okay, if the signal is this, then the quality of the call is this, and so on. They will be providing some training data, and this training data is what is going to be applied to each call to determine whether it is a call of good quality or a call of bad quality, and then the further analysis is what caused the bad quality and so on. So again, the training data is sort of the development of training data is a very important aspect of this.
Yeah, but Partha, I was talking a little different, right? So in the real time, in the world that I live in, right? The training data are not, the data that is coming to us are not clean, right? It comes to us and it's all standards, right? And all these data has certain meaning to it, and it is as per standards. And all these things comes in real time and gets fed into the algorithms to create a pattern, detect the anomaly, and then even take a corrective actions automatically, and even predict in future what kind of an anomaly is going to happen, and prepare the people today so that they can mitigate that anomaly can happen in future, right? So this is what is happening in my field. So now I was trying to map to what Shad was saying, right? In this case, there's no data engineering stuff is required, because the data need not have to be cleaned, because it's already coming in as a data. And when it is coming in, there is some model and algorithm has to be written to create detect the pattern and detect the anomaly. I think that's what the data scientist probably would do. I'm just trying to map to what Shad was saying. Does it make sense or no?
Yeah, it makes sense, but you have to explicate this much more, because anything can be, if you first you have to develop a model, and then the model can be applied to either streaming data or to collected data. It doesn't matter.
Okay.
So
And the model is developed by data scientists, right? Together, obviously.
Yeah. So one of the first, what we are learning today is how do we take a massive set of data that's already collected, and then how do we start, categorizing it into this is data of if I have some standards. This falls into standard 1. This falls into standard 2. This falls into standard 3. We definitely need some sort of training data to actually build a model that will classify, and then you can apply that model to whether it's streaming data or not, non-streaming or collected data. It doesn't matter. That's what we do. So I believe, in the technology field, or sorry, in the telecom field that you're talking about, it's exactly the whether it is applied to live data or collected data as an after, as a post call detection. You will still do that, and then from again a mass of data collected, you would provide a model saying under these circumstances we are going to have poor call qualities, and on these dates of the month we have extra traffic, so we may need to pay attention to where's are going to be our peak. And anyway, long topic.
Yeah, I got the point, but you're correct. And then I think the message that I got from you is pretty clear, right? Even though all these things happens through the streaming data, but before even you put it in the production system, you need to build a model. You need to use it with some training data to make sure it is it has its fundamental things right, and then put it in the production to automatically learn by itself over the period of time and mature. So one question, Shad, the last question, and then we can kind of start. Next 30 minutes, we can give the floor to you. Well, all these things are good, right? And we are detecting the pattern, and we are flagging whatever that issue is coming up, if it is outside of the pattern, and that's what we are learning through different algorithms and so on. there is a one piece called as a prediction, right? Based on the past data, the future problems are predicted. And what is that, and where does it fit into what you guys are teaching, or is this something that's not covered? Will we plan to cover next year? This is the last question. The prediction portion of it.
Yeah. So prediction in so the different ways in which predictions happen. So a recommendation engine, for example, tries to predict what is the next thing you're going to do. So for example, if you are on Netflix has a recommendation, very complex recommendation engine in place, right? What they try to do is they try to and figure out using all your activity and your history what is the next thing you want to watch, and they also record whether or not you saw that or not, right? So whatever you decide, whether it's watching it or not watching it, that goes back into the recommendation engine, and so the next recommendation that they have for you would be much better. So their prediction improves the more data you provided. Recommendation engines we haven't covered in this course. They're a bit more advanced of a topic, but that is an example of how these predictions work, right? And again, the core mechanism of the predictions is, again, it's the same thing, classifiers and regressors. But here we gave an example of how classifiers and regressors work. Using that same thing, you can make these other recommendation engines, or you can figure out what the future is going to be and then improve based on the data from the events. Another part of this is something that's called time series analysis. We didn't cover that here at all, which is a more direct way of trying to figure out how a previous trend or pattern or seasonality can go out into the future, right? So if you're doing like tracking portfolios and you want to do a time series analysis on it, that is something that a data scientist should know as well. But again, that's also something we didn't cover here because that's a very specific topic.
All right, perfect. So guys, thanks for putting up. So for some of I was trying to. I've been attending this session continuously. I was trying to kind of map that to the practical aspects that I'm seeing. On the business side of the world, and I think I got good answers. Hopefully, I didn't waste your time. And thanks a lot. And as you see from the Shad and Harsha's point of view, there's so many topics that we need to cover. So what we are planning together as a team is, next year, we're going to create 2 master classes on this, 2 6-week sessions on this, where we're going to obviously have a redo of what we did, and also go into some advanced topic as much as that we could do in 12 weeks of session for the next year. So stay tuned. All those different sessions will be created in the Eventbrite. For the whole year. By mid-December, we should have the complete year plan for the next year, and I hope that you all get benefited out of that. So having said that, I'll kind of hand over the session to Bala and Shah. Sorry, to Harsha and Shah to take it over for next 30 minutes. Thanks, Harsha and Shah.
Okay, thanks, Kader. Okay, so what we have seen so far in these sessions, we saw an introduction to machine learning, the different types of machine learning in the form of supervised and unsupervised learning. We saw 2 techniques in supervised learning, linear regression and logistic regression, and we saw clustering technique, k-means clustering technique in unsupervised learning. We went to that part because model is the the most interesting part in any machine learning software building process, right? So we did that, but in real world you don't straight away go there. There is a lot of work which is done before that itself. One of the most important steps is the exploratory data analysis. There are other steps also, but this is something exploratory data analysis helps us understand the data, what has been provided. I'll talk about a few of the steps which are there towards building the machine learning model. And briefly, we have half an hour. I'll briefly touch upon some of the Python libraries which can be used for doing exploratory data analysis. So to start with, right, we need to define the business problem properly. like what is that we are trying to achieve. I'll quote what we have read in Alice in Wonderland. So the cat, when Alice asks, like, the cat, which path do I take? And the cat asks her again back, where do you want to go? And Alice says, I don't know. And to that, the cat says, it doesn't matter which path you take because you don't know where you're going to go. So this is very much applicable for machine learning also. You need to know what is the goal you're trying to achieve. So first thing is like you need to define the problem. And after you define the problem, what you do is you build some hypothesis, right? You know that domain and then you build some hypothesis. I'll give an example. The notebook which you're seeing now is exploratory data analysis for retail demand prediction. This is a course I've taken from Analytics Vidya. It's a big one. It's very interesting, but I'll just tell you how it is being applied and then I'll move to our session on Numpy and Pandas. So this one, if you see, the retail demand prediction, that domain, like what is the behavior, what are the characteristics of that. Based on that, you have some hypothesis. For example, like since it's retail, you say that, I'm just giving an example. A bigger packet sells more. This is a hypothesis, and you have data with which you check whether the hypothesis is true or not. You do all this hypothesis checking. And then what you do, what is important is you should do the hypothesis building before data so that you don't get any bias from the data. So you have a general idea, build some subtopics out of that which you want to check with your data. And after you do the exploratory data analysis, decide what is based on the business goal, what model you're going to get towards. In between, you might have to transform the data before you feed it into the model. And as one of the steps in the model building, we also identify what will be the metric with which you will determine whether the model is performing fine or not, because you can have several possibilities. If you're going to look at whether you're going to use linear regression, are you going to use decision trees, are you going to use random forest, all these things will be there. But for all these things, you should know which model you're going to choose for your final output. And for that, we need to know the metric which we are going to use. So if you look at it, if you look at the steps, as it is mentioned here, it is like you define the problem, the data description which you have in hand, and then look at hypothesis building. You have few ideas from the business side of it, what you have, what you know, and use the data, load the data, explore the data, check whether your hypothesis is working fine, and then you build the model. And before you build the model, you have the metric which you need to identify for ensuring which model, for helping you choose which model you'll have to use. So there are several steps involved towards building a machine learning model. After this too, deploying to production is another big part. There are a lot of details there, but at a high level, these are the main steps which are involved, which we'll have to do towards model building. There is a statement, right? Genius is 99% perspiration, 1% inspiration. That's very much true for machine learning also. So you have like tons of work being done before you actually get to the model building, training the model, seeing the output, modifying the parameters, all those things. So in those steps, amongst those steps, exploratory data analysis has a very, very important role to play. With a real example, I'll tell you what an exploratory data analysis. I told you about the retail demand prediction model, which is the goal of this exercise. So the whole idea is you predict the demand, how much is going to be the sale for a particular product. If when you predict it, what you're preventing is you're preventing an overstocking and understocking of those items. How we arrived at this? The first problem statement was the business is running at a loss. This was the first problem statement. OK, when the business is running at a loss, what are the reasons for this? Is it the sale? Is it the cost? And in that you go to cost. What are the factors which are affecting cost? If it is cost, like are we spending a lot on the stocking items, or are things perishing when you overstock items? So all these things question came, and finally it was decided that this will be the problem which we are trying to solve, so that it will help you optimize your costs, thereby helping you avoid losses. So we define the problem and we know data is there. What we mean by trained data is the actual sale data. We have data. There are three important files which we will be using: train data, product data, and the store data. There are various parameters which are there in that data. You can join these things based on UPC. Like you can join these two with common parameters, if any. So do those things, and then you'll have to look at building a model with which you will be able to predict what is going to be the sale for a particular item, so that you can stock accordingly. You prevent losses due to overstocking or understocking. Okay, so I'm not going to delve a lot in this file because it's a very big file, but I'm just showing you a real world example how it is done before I move to the Numpy and Pandas introduction. Okay, so what you do is you first load the data, you understand and validate the data, like what is the type of data which is there. Do you have something which you'll have to change for you to analyze? For example, if you look at the weekend date, which is not, it's not in a date format, it's an object which is stored. This is from the file which has been received. So if in this case you'll have to change it to a datetime variable, you use a pandas library to change it, and then you see whether there is missing data. Is the data making sense? Like they've said, like for these many weeks there are the data is there. Is it there for every week? For every week, what is each store selling, or is each product on sale every week? Do you have few other parameters like there are promotions with which like it is featured or it is in special display? Are these things affecting the sale? You have the size of the product, the category of the product, subcategory of are there any correlations? You have the store location, you have parking data, you have location values. Is this affecting the sale? All these things you'll have to know. So you do the analysis for with all these things, and this is a pretty big file. There are several segments of code, if you can see, that is being entered for you to come to few conclusions. You also check your hypothesis, which you had developed initially when you defined a business problem, and you come to some conclusions based on whether it's not just one line hypothesis. You will have several hypotheses which you'll be making, and you check whether those assumptions are correct. And then depending on that, you build the model. What parameter has to be passed into model? What additional parameters you can get based on the data which they have provided? And then you look at model building. So this is exploratory data analysis, which is done as a very detailed processing before we get to model building. And it's an important step in model building. Any questions till now? Shall I?
No, Harsha, it's good.
Okay. Shall I? Okay, fine. I'll thanks for the clarification. Saad, you want to add something?
No, I think you covered everything. That's
okay, fine. Okay, so this is the usage of exploratory data analysis. What do we use for doing this is what we are going to cover now. There are Python libraries. I'm starting with Numpy and Pandas. Of course, you would have seen some visualizations in this file, and that is done with matplotlib. Before we go there, the analysis part will be done with Numpy and Pandas. So with that, I'll move to Numpy. I'm starting with Numpy because this is the bedrock for many other Python libraries, including Pandas. So if you look at the series for Pandas, is built on the Numpy array concept. So I assume Numpy will be installed. You can do it if you have Anaconda distribution. You do a conda install Numpy, or if you don't have, then pip install Numpy. And once it's installed, you import it. And what does this library provide? So you can do few things with which it's a linear algebra library. You can do few things with this library, which will help you in your data analysis. For example, you can build an array. You build a NumPy array with either from a not the linked list, sorry, from the list in Python, or you construct that array with some of the parameters, some of the functions which are already there. For examples, or when you're doing matrix operations with identical matrix, you can also do that with numpy.i, give it the size and then do that. You can also do some random number generations. You can look at shaping and reshaping the data. That is like you have a matrix, you have a vector of vector means single dimensions. If you have a 10 element vector, then you can convert it to a 2-dimensional thing, 5 into 2 or 2 into 5. Those things can be done. Find what is the maximum value. There are a few standard functions which you can do some data, filter out data, index it, segment it. All these things can be done. So the first step is like creation of NumPy array from a list. So what it does is like it is I just declared a list and then just using npy.array create from this array one. Okay. So at the list, and we can use this array for operations.
Harsha, I'm sorry,
then,
I don't know. Is it just me or everyone? Is the quality of Harsha's call is good for all?
No, it's breaking color.
Yeah.
I have some internet issues. Looks like 1 minute. I'll switch it to another network. No, the other network is not visible. 1 minute. Shall I drop off and join back? I'll try that.
We can wait for you. Yeah.
Okay.
Shad, while Harsha is joining, a question for you, right? So, okay. I'll take it up offline. I'll call you later.
Okay. Is it better now, Kader?
Yeah, so far so good. Yeah. I was wondering because even before when you were talking, there were some issues. I thought it was just me, but yeah, I wanted to double check. It's good that I double checked. Yeah, please go ahead.
Okay, fine. Sure. So some of the NumPy operations is what we are going to look at. Are you able to see my screen?
Yes, sir.
Yes. Yeah.
Okay, fine. So this this function we can use for creating a NumPy array with just a range. So give the starting and ending because like it's not the last one is not included. So you have you create that, and with that it lists the elements. Default interval is taken as 1, or if you want to give an interval, you can also mention the interval at which the range the array has to be created. That can be done, and then you have a way of like if you need to create during linear algebra operations, if you want to create an array with zeros, that can also be done. Ones, same thing. This is more like with a space, like you have 3 elements. This give it as a range, and then you create 3 elements from there. You can create identity matrix with which you use this for your matrix for your linear algebra operations. Identity matrix, as some of you might have known, is the one which has the diagonal as 1s, the rest of them as 0. You can create random numbers if you want to use it for testing with some random inputs or something like that. So you create this with a random.rand function. You mention the number of number of elements you would need. If you declare that as a tuple, you will get a 2-dimensional array, but otherwise you will get a single-dimensional array. You can also specify whether it has to be integer or not. You say that if you want integers, random integers between 1 and 100, say 10 integers, then it generates an array random number which you can use. Look at reshaping some of the arrays which you will use in your linear algebra operations. If you have like, say, this is going to be, if you declare an array which has got a range 25, it's going to give you a single dimensional array. The same thing can be reshaped into 5 by 5. Of course, these two, the product will have to match the number of elements. This is just random in finding the maximum from the array which has been declared, or finding the position of the maximum element. We can do the same thing for minimum also. This is filtering the data. Say for example, if you have if you have an array and you find out you want to find out which values are greater than 4, you do this. Say where this will be used is if you're doing exploratory data analysis, you want to find out like I spoke about a store having a display for a particular product, right? And there'll be other products which will not have a display. So if you want to filter out data where you only have the displayed products and look at the influence of that on sale, then you can say that display is true and take that filter that data, see those things, how the sale has been for those products, and come to some conclusions with which you can build the model in a better way. That is how this feature will be used. So the same thing, what has been done is, like, if you just have the condition here, it's going to give a Boolean array, which is going to say like which element meets the condition or not. If you just pass that again to the array, then what it will do is it will give you the result for those conditions. And you can do various operations with NumPy array like addition, subtraction, multiplication, division, all those things can be done. So this is introduction to NumPy array. Based on this, we'll move to Pandas, and Pandas you have series and data frame. We'll be primarily talking about data frame, but series is built on NumPy array with which like several of these operations will be used. Any questions till now?
So I have a question regarding the reshape. If we give 5 by 5, then it's fine. But if we give 4 by 4, it gives error. Or?
It will give an error. We'll try it out.
Yeah.
It will say cannot reshape array of size 25 into 4 by 5.
Yeah. And this is out means this is the output. It is the live output we can see, right? Whatever we input.
Yeah, we can see that, or we can store it in another variable and then use it also.
Okay. And so where exactly this can be used? Maybe in later sections, right? We can.
Yeah. See, what would happen is you can use it. See, reshape is just one example I can think. I had actually used it in when I walked through the logistic regression code. If you're concatenating data from two separate files, and then you want the output in a particular format, then you can look at doing a reshaping also. That's one application of reshaping. Saad, any other application you can think of?
Of reshaping?
Yeah.
Not at the moment. I can't think of one right now. Usually when you feed a NumPy array into a some kind of algorithm, if it wants to do reshaping, it's going to do it itself on the array. So that's something that could happen on the back end that you just don't know about when you're using a some kind of model.
If it is needed, it can be done. And if you are passing some inputs to the model with a particular parameter, then the model expects the data with a particular shape, then you might have to reshape and pass it, right? Only then it will accept.
Yeah. If it has that particular requirement. Otherwise, if it's going to do some reshaping in the backend, then it's going to do that anyway. It doesn't matter if you reshape it or not.
Yeah. Have I answered your question?
Yes. So whatever what all inputs are provided just for our knowledge purpose right now, right? We can use it later, like in our applications or.
Yes. Yeah. I'm just telling you this so that like when you go to actual model building, when you do exploratory data analysis, you
Mhm.
will be familiar with some of the operations which are taking place.
Yeah.
Okay.
Thank you.
Okay. With that, I'll move to Pandas. We have 7 minutes. So Saad, what do you suggest? Shall we stop here, because we'll not be able to cover a lot of things in Pandas? Shall we stop here and continue in the next session?
Maybe look, the Pandas one is pretty long. Yeah, I think we should stop here. The Pandas one is quite a long workbook, so it makes sense to stop here.
Kader, what is your suggestion?
Yeah, let's do that. I just want to make sure that whatever the rest of the things that you have, would you be able to cover it by next week? There's one thing that I noticed, right? So because our Python program was ended a week before, the event by entry is kind of vanished, right? Because it came to an end. That could be another reason why, we started seeing from the last week less number of participants, because some of them thought it's got over. I don't know. I wasn't really sure, right? So just want to give that as a thought. And on follow up to that thought, Harsha, I was just wondering, whatever that you had plans to complete, do you believe that you would be able to complete it next week or a week after?
No, we can complete it next week, Kader, because there's a slight change. We are going to cover matplotlib next week, which is going to be the visualization part. See, of course, all these things, NumPy, Pandas, matplotlib, all these are you can have several sessions for these topics, but we are only introducing it to folks so that they can build on what we have introduced. So we can cover on Pandas and matplotlib next class.
Awesome. Yeah, this is an introductory class, I understand. And next year we will create a detailed 2 6-week sessions, that's as we discussed, right? To deep dive and yeah, so let's do that. So next week would be our last session for the intelligent automation codeathon, and with that, I think the intelligent automation codeathon track would be completed for year 2020. Okay, so at least I want to make sure that whoever is in this call, they join next week for those and close it together and clap together and say goodbye for the year, at least for this program, and we'll see next year for additional new programs. So I kindly request everyone to join, whoever at least are there, so that consistently we can complete it next session with 14 participants. All right, Harsha, let's close the call as you recommended.
Okay.
And yeah, I think the less number of attendance since last 2 weeks, that could be the reason. Let's make sure that next time we plan it together properly. It's an organized mistake.
Okay, that's fine. No issues.
Perfect.
Yeah.
All right, so you guys have a great
Thank you, everyone.
Halloween, I guess, sitting at home. All the very best. Enjoy yourself. Bye-bye.
Okay, bye.
See you guys next week.
Right. Thanks, everybody.
Thanks. Thanks, everyone.
Thank you very, very much.